UDEFENSE Systems develops drone with hidden microwave reflector. An unmanned aircraft equipped with a microwave retroreflector, a device that bounces radar signals back with the strength of an object roughly 20 times its actual size, is designed to make one radar blip look like a genuine incoming strike drone. That aircraft, called Spectr, is built by UDEFENSE Systems, a UK-based defense technology company that builds its own drone systems and manages an integrated supply chain from raw materials through finished hardware. Spectr functions as a smart decoy and built to trick, distract, and exhaust an enemy's air defense network before real strike drones arrive. The problem Spectr addresses has become one of the most expensive imbalances in modern warfare, and it cuts against Western, Russian, and Chinese air defenses alike. A single U.S. Patriot interceptor missile costs the U.S. military roughly $3 million per round, while Russia's S-400 system, which China also operates under license and export purchase, fires interceptor missiles estimated at $1 million to $2 million apiece, and relies on a full battery that runs into the hundreds of millions of dollars. A Shahid-type attack drone, the kind Russia has launched into Ukraine by the thousands, can be built for as little as $30,000. That gap means every intercepted drone can cost a defender anywhere from 30 to 100 times more than it costs the attacker to send it, an arithmetic problem no military, American, Russian, or Chinese, can sustain once drone swarms scale into the hundreds or thousands at once. UDEFENSE Systems frames this imbalance as the central failure of legacy air defense, arguing that electronic warfare systems built to jam drone signals grow less reliable as drones become more autonomous and less dependent on radio links to fly, while gun-based defenses cannot track and destroy enough small, fast targets quickly enough to matter at scale. Spectr is built to attack that math from the offensive side. Rather than trying to sneak strike drones past an alerted defense, decoys launched in numbers alongside a real strike package return radar echoes indistinguishable from genuine threats, forcing air defense crews to expend scarce interceptors and tie up radar resources and operator attention on targets that were never worth shooting down. There is a second-order effect as well. Every radar that switches on to track a decoy reveals its own position, exposing air defense sites to detection and follow-on strikes. UDEFENSE Systems describes Spectr as a click-and-go automated decoy, meaning operators can prepare and launch it from its catapult with minimal setup rather than the lengthy coordination legacy systems typically require, and the company says it is designed specifically to overload enemy air defenses during real strike packages rather than operate as a standalone deception tool. The microwave retroreflector at the heart of Spectr's deception is the component that does the actual work of fooling radar operators. Weighing 1.2 kilograms, 2.6 pounds, and tuned to operate across a frequency band of 3 to 20 gigahertz, the reflector is engineered to make Spectr's genuine radar cross-section appear roughly 20 times larger than it actually is. UDEFENSE Systems presents that multiplier as the difference between a decoy that gets ignored and one that draws real interceptor fire, whether that fire comes from a Patriot battery, an S-400 launcher, or a comparable Chinese system built around the same targeting logic. Radar cross-section, the measurement that determines how large and threatening an object looks on an enemy's screen, is normally something engineers work to minimize on stealth aircraft. Spectr inverts that goal entirely, using the reflector to make a lightweight, inexpensive airframe present itself as a target worth shooting down. The aircraft's structure reflects that cost-conscious design philosophy throughout, a PVC body powered by a pusher motor mounted at the rear, launched from a catapult, with a separate navigation unit and an onboard electronics and battery package rounding out the airframe. UDEFENSE Systems has not disclosed a per-unit cost, range, or endurance figures for Spectr, but the use of PVC construction and a comparatively simple propulsion layout points toward a system built to be produced and expended in volume rather than recovered and reused. UDEFENSE Systems says Spectr has reached Technology Readiness Level 6, a milestone on the NASA-derived scale used by the Pentagon and NATO, indicating a system has been demonstrated in a relevant environment, and that the aircraft is currently undergoing field trials with the Ukrainian military, testing that, if successful, would carry it into the operational demonstration territory of TRL-7. That detail places Spectr squarely inside the conflict that has driven much of the recent innovation in low-cost drone warfare, where Russian air defenses, many of them S-400 batteries, have had to contend with wave after wave of cheap Ukrainian drones and decoys designed to do exactly what Spectr claims to do. Ukraine's military has become one of the most closely watched testing grounds in the world for this kind of technology, and a system validated there against actual Russian radar and missile crews carries a credibility with potential NATO and allied buyers that laboratory testing alone cannot replicate. Spectr does not operate in isolation within OM Defense Systems' broader portfolio. The company positions the aircraft alongside Kestrel, a separate hard-kill drone interceptor built to physically destroy hostile drones, describing the two systems as complementary layers within a single air defense concept. Spectr saturates and exhausts enemy defenses while Kestrel handles the actual destruction of threats that get through. That layered approach reflects a broader shift underway across the defense industry, where planners increasingly treat drone warfare as a numbers problem rather than a precision problem, betting that the side able to overwhelm the other's decision-making and interceptor stockpiles the fastest will hold the advantage regardless of how sophisticated any single weapon is. What Spectr ultimately represents is a bet that the next phase of drone warfare will be won less by building better missiles and more by making an enemy waste the expensive missiles it already has stockpiled. A cheap, hollow airframe carrying a passive reflector engineered to lie convincingly to a radar operator costs a fraction of what it forces an adversary to spend defending against it, and that is precisely the kind of math that decides whether a military can keep fighting a drone war for months rather than weeks.